What happens when you heat up a rubber band? You might think, just like most materials, it would stretch or weaken. But if you've ever tested it, you'll know that rubber behaves very differently from other materials when heated. So, what exactly is going on at a molecular level? Let's dive deep into the science of heat and materials and explore why rubber is unique. To understand the behavior of rubber, we need to first look at how most materials react to heat. When you heat up a material like glass or plastic, the heat causes the atoms to vibrate faster. This increases the energy of the particles, and as a result, they tend to move farther apart from each other. The distance between molecules increases, and this weakens the intermolecular forces that hold the material together. This results in the material becoming softer and more easily stretched under tension. But rubber doesn't follow this rule. When you heat up a rubber band, the opposite happens. Instead of becoming weaker, rubber becomes tougher. It pulls more strongly and actually contracts when heated. So why does rubber behave differently than other materials? Let's break this down. Rubber's elasticity comes from the unique way its polymer chains are cross-linked. Cross-linking is a process where the individual polymer chains are chemically bonded at various points, creating a network of interconnected chains. This structure allows rubber to stretch and then return to its original shape when the tension is released. When rubber is heated, these crosslinks become more rigid, which increases its strength. It also reduces the ability of the material to deform easily, causing it to contract instead of stretch. This is why rubber bands become tougher when heated and are able to withstand more force. So, how does temperature play into this? In most materials, heating causes the atoms to move more and the material to weaken. But with rubber, the polymer chain's ability to move and contract under heat means the material can handle more stress as it heats up, increasing its tension strength. At low temperatures, rubber behaves more like a typical solid, but as it heats up, the polymer chains gain more energy, allowing them to become more flexible. The rubber's toughness increases because the cross-linked structure becomes stronger, allowing it to stretch under greater tension. This is why heated rubber bands tend to contract under load. They're essentially becoming stronger and more resistant to stretching. This unique property of rubber has real-world applications. In fact, rubber is used in countless industries because of its ability to return to its original shape and handle significant tension. From tires on cars to seals and gaskets in machinery, the way rubber behaves when heated is critical for performance.